I'm going to go through the homework solutions from Wednesday's work, and that was on page 95 of your book, questions 1 to 3, working with laws 5 and 6 of indices. So for question 1, they were asking us to use the law about negative powers, putting the base and the power under the line in order to write the following things as fractions. So 3 to the power of minus 3 would be 1 over 3 cubed, and you would be expected to simplify that there to 1 over 27. Part B, 5 to the power of minus 2 is 1 over 5 squared, which simplifies to 1 over 25. Part C, 9 to the power of minus 2 is 1 over 9 squared, which is 1 over 81. Part D, 7 to the power of minus 3 is 1 over 7 cubed. And I don't happen to know the cube of 7 off the top of my head. My calculator is not here. Let me just use the calculator on screen. That is 1 over 343. And part E, 4 to the power of minus 1 is just 1 over 4 to the power of 1, or 1/4, 1 over 4. And part F, 2 to the power of minus 5 is 1 over 2 to the power of 5, and that's 1 over 32. So we can change them into fractions just like that by changing the minus power, moves the base number and the index below the line. Now, question 2 was asking us to use the fraction power or to be able to evaluate roots without using a calculator. So how do you do that? Well, it involves some knowledge, and you probably would use a calculator for some of them to get used to it, but the square root of 100, that's something that we can do without using a calculator. We know that's 10 because 10 to the power of 2 is equal to 100, and a power of a half, or a square root and a square, are the opposite of each other, so they cancel each other out. That's what we're doing there. Okay, the next part then, part B, the square root of 144. That's the square root of 12 squared, because 144 is 12 squared, so that's just 12. So these are ones we would be expected to know. The cube root of 27. Well, if you remember in part 1, 3 cubed was 27. So that means that the cube root of 27 is 3. Now, I'm going to make a quick note. You should know, and I've said this to you before when we took them down, you should know your first 10 squares, first 10 to 15 even, square numbers. So you should know that 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81. We all know the 12s anyway. 10 squared is 100, 11 squared is 121, 13 squared is, sorry, why did I skip? 12 squared is 144, etc. So if you know the first 12, you know them from your times tables. You should know them anyway. And you should also know the first 5 cubes. Cube numbers. What are cube numbers? Our perfect cubes are 1 to the power of 3, which is just 1, 2 to the power of 3, which is 8, 3 to the power of 3, which is 27, 4 to the power of 3, which is 64, and 5 to the power of 3, which is 125. So I would expect you to know all of those, which means, of course, then you know the cube root of them. The cube root of 1 is 1. The cube root of 8 is 2. The cube root of 27 is 3. Cube root of 64 is 4. And the cube root of 125 is 5. So you should be able to go backwards and forwards with squares and square roots for the first few numbers without using your calculator. That said, can they tell whether you've used your calculator or not? They can't. They can't. But it does help in solving some problems if you're aware of some of these. Now let's move on to part D. We're looking for the fourth root of 16. And that's just 2. And again, it's because 2 to the power of 4 is 16. The fifth root of 32, excuse me. And again, remember in question 1, you start to get used to them when you've seen them a few times. In question 1, 2 to the power of 5 was 32. So the fifth root of 32 is 2. Part F, the 10th root of 1. Well, 1 to the power of 10 is still 1. So 1 to any power is just 1, regardless. The cube root of 1000, that's 10. Again, because 10 cubed is 1000. So our powers of 10 are very easy. We just stick on that number of zeros. So then they do expect you to know the roots of those. The fourth root of 81. Okay, this isn't in our list, so you might need to go to the calculator for it, but you might have a guess as well. It's 3, and again, because 3 to the power of 4 is equal to 81. 9 squared and 3 to the power of 4, they're the same thing. I, the sixth root of 64. Okay, again, you probably wouldn't know and you'd need to use your calculator to help you, but it's 2 because 2 to the power of 6 is 64. One way of thinking about that is that if 2 to the power of 5 is 32, multiply it by 2 again, and you get 64. J, the cube root of 125. That is in the list of the 5 that I mentioned earlier. So I would expect you to know that that is 5. So the moral of this question, or the point of this question, was just to get you used to powers, some common powers of numbers. Even though this homework question asked you to do it without your calculator, they can't really expect you to do this without your calculator because there's no way of showing the work for it. But this is the reasoning behind it, and I could have written down the same thing for all of them. Some of them were more obvious than others. The other thing is that you should know at least your first 12, maybe even up as far as 15 square numbers, and you should know your first 5 cube numbers and their cube roots. Okay, let's go through question 3. So question 3 was emphasizing the difference between square numbers and square roots. So for question 3, we were listing out different values of x, and if they were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we want to do the square of each of those. So we're going to be filling in the square numbers for x. And we've already done this on the other page, so I'll go quite quickly. 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. That's our first 10 square numbers. So then, if we have square numbers, we start with square numbers rather than whole numbers. Well, they're still whole numbers rather than sequential numbers. 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. If we start with these, what are the square root of each of them? So this is just emphasizing how squares and square roots are the opposite of each other. The square root of 36 is 6. And again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's all you needed to do for question 3. I don't think there was any difficult maths there, but maybe there was a little bit of confusion about what you're being asked to do and how important it was to not use the calculator. Okay, do please let me know on the Google Classroom, on today's Google Classroom, if you have any questions or there's anything that you're still uncertain about with that. Thank you.